In this section, we're going to look at the dot product of vectors and projections. Given the vector u and the vector v, find the dot product of u and v. So we write the dot product of u and v as u dot v, and it is equal to the sum of the product of u1 times v1 plus u2 times v2 plus u3 times v3. Now the dot product allows us to find the angle between the two vectors u and v. And how we do this is with the following formula. The angle between vectors u and v, which is theta, is equal to the inverse cosine of the ratio u dot v over the magnitude of u times the magnitude of v. Now let's find the dot product of u and v, or u dot v. And that is going to be the product of 1, the one that's in front of this I, times the 6 that's in front of this I, plus the product of -2 times 3, that's in front of the j, plus the product of -2, which is in front of the k, times 2, which is in front of the k for v. And let's move this up. Oh, I guess it's not coming all up together, that's fine. So this is equal to 1 times 6 is 6, plus 2 times a -3 is a -6, plus -2 times -2 is a -4, and of course the 6 and the -6, they're additive inverses, they cancel out, so the dot product is -4. Now let's find the magnitude of u given its I, j, k components. The magnitude of u is equal to the square root of the sum of 1 squared plus a -2 squared plus a -2 squared, which is the square root of 2 times 2 is 4, plus 1 is 9, so it's 3. So the magnitude of u is 3. Let's move that up here. Now I'll change the color to black. Now we're going to find the magnitude of v. The magnitude of v is the square root of the sum of, from the v vector, 6 squared plus 3 squared plus 2 squared. And that is going to be the square root of 36 plus 9 plus 4, which is the square root of, let's see, 36, 45, 49. And let's move this up. And of course, the square root of 49 is 7. Now I'm going to switch to blue. And we're looking for theta. And theta is equal to the inverse cosine of the ratio of u dot v divided by the magnitude of u times the magnitude of v. Well, we found u dot v in our previous slide, and it's -4, so let's put that in. And on this page, we found the magnitude of u, which is 3, and we're going to multiply that by the magnitude of v, which is 7, and this becomes a -4 over 21. So at this point, we are going to find theta by using our calculator, and we're going to put it in what is the inverse cosine of a -4 divided by 21. And when we would put that into the calculator, well, we get, let me make that approximately, that's sort of not quite an equal sign, 100.98 degrees. So I would round that to 101 degrees, and that's theta, the angle that is between u and v. Let's box that answer. Now here we're going to look at the projection of vector u onto vector v. And the formula for this, the way we write it, is we write PROJ for projection of u onto v, and v goes down here, and it is equal to the ratio of the dot product of u and v, u dot v, over the magnitude of v squared times vector v. Let's move this up. This is going to create a vector, a new vector, that is parallel to vector v. This is parallel to vector v, and hopefully I can pick that up there. I guess we'll put that down here. So this is going to be parallel to vector v. Now if we want a vector that's perpendicular, then we will take u, and from u we will subtract the projection of u onto v, and this, oops, that's connected to that, okay. This is going to give us a vector that is perpendicular to vector v. So this is what the projections formulas give us. Okay, we're given two vectors, u and v, and what we're going to do here is write u as the sum of a vector that is parallel and a vector that is orthogonal to v. Orthogonal does mean perpendicular. So the formula that we're going to use is, first we want to find the projection of u onto v, and that is going to be u dot v divided by the magnitude of v squared multiplied by the vector v. And then we're going to take vector u and subtract this projection of u onto V, and that's going to give us our orthogonal vector. Okay, so let's find the projection of U onto V, and we're going to start by taking the dot product of U and V, so that's going to be 8 times 1 plus 4 times 2 plus a negative 12 times a negative 1. There's our dot product. And that's going to be over the square root of, and this is now where you have to find the magnitude of V, so the square root of, you take these components, 1 squared plus 2 squared plus a negative 1 squared, and then all of this is then squared, and then this is multiplied by vector V. So let's work this out. Here we have, back to our pencil, 8 plus 4 times 2, which is 8, plus 12, which is negative 12, times 1, and this is divided by the square root of 1 plus 4 plus 1 times vector V, and in the numerator we have, let's see, 28 in the numerator. In the denominator we have the square root of 6 all squared times V, and that becomes 28 over, and if you square a square root, you get, they cancel each other out, we have a 6. And then if we cut the numerator and denominator in half, we have 14 over 3V. And we're almost done. Now to finish this off, we're going to take the 14 over 3 and multiply that by vector V. And vector V is I plus 2j minus k. And let's distribute the 14 over 3, and we get 14 over 3I plus 28 over 3j plus a negative 14 over 3k. And this, let's put a box around it, is the vector that is parallel to vector V. And this vector is a vector that is parallel, and the symbol for parallel to V, and the symbol for parallel is 2 double lines. Now we need to find the vector that's perpendicular to V. And to do that, we want to take U, and from U we want to subtract the projection of U onto V, which we have calculated, and I've listed it above. And so U is 8I plus 4j, you can see that above, minus 12k. And from that we want to subtract 14/3 I plus 28/3 j minus, I'm running out of room here, let me move this over, minus 14/3 k. and I should have arrows over these because they're vector components. And when I do this, I get, we want to have a common denominator. So I have 8 times 3 is 24, so 24 minus 14 over 3, and that's in the I direction, plus, and here now we have to have 4 times 3 is 12, so 12 minus 28 over 3, and that's in the J direction, plus a negative 12 times 3 is a negative 36 plus 14, all over 3 in the K direction. And let's work these out. The first one is 10. 24 minus 14 is 10. 10 thirds I plus a negative 16 thirds J plus a negative 22 thirds K. That's a vector. And let's put a box around this. This is our vector that is perpendicular to V. So we can say that this vector is, here's our symbol for perpendicular, perpendicular to V. Now we're going to take our perpendicular and parallel vectors and we're going to sum them up. So we end up with 14 over 3 plus 10 over 3 in the I direction, plus 28 over 6 minus 16 over 3 in the J direction, plus a negative 14 over 3 plus a negative 22 over 3 in the K direction. Let's move that up. Somehow we lost our plus sign. Let's put that back there. Okay. Okay, so let's work this out, and what we get is 14 and 10 is 24 over 3 in the I direction, plus, and here we have, let's see, this comes out, if we calculate this out, 28 divided by 6, if we cut that in half, right here, if we cut this one right here, that's actually 14 over 3, isn't it? So 14 over 3, if we double that, that's 28 over 6. So 14 over 3, 14 minus 16, that's a negative 2 thirds. Ooh, I want to go, let's go with black. Let me, can I undo that? Let's write over negative 2 thirds. J, and then finally, the last one, we have, let's take a look up here. We have a negative 22 and a negative 14. So that's a 2, 3, a negative 36 divided by 3. And that's going to give us minus a negative or minus 12 in the K direction. And so this, what we have here, this is the sum of both the perpendicular and parallel vector.